Here I am in my EC2 dashboard. SoftNAS 1 is running in zone US West 2A and SoftNAS 2 is running in zone US West 2B. For redundancy, both of these are running on AWS, but one could very well be a virtual machine or hypervisor on-premise as one of these nodes for disaster recovery purposes. Note that SoftNAS 1's IP ends with .26 and SoftNAS 2's IP ends with .112 for clarity when they're running simultaneously in the browser. I've already launched both of these. The first thing you do is to add a disk device. On the left menu, I click on Disk Devices and then I click on Add a Device. You have a choice of using S3 or EBS. Which one you choose depends on your business needs. I'm going to choose S3 and click Next. You choose the region where your EC2 instance is running, and then you can call the bucket base name anything you want. And when you do that, the name of the S3 bucket changes along with it to match. I'm going to choose to launch 2 devices, each with 10 gigabytes, and then click Create S3 Cloud Disk. As you can see, the 2 S3 disks were created. Now you go to the second instance, click on Disk Devices, and add a device. They have to match for replication purposes. So I'm going to leave it on S3 and I make sure it's in Oregon, 2 devices at 10 gigs each, and create S3 Cloud Disk. And you can see they're created. Back in the first SoftNAS instance, the next logical layer is to create a storage pool where we can aggregate disks. On the left side, I click on Storage Pools and then I click on Create. I choose Standard Pool and click on Next. I give the pool a name and then select the RAID level. So for the RAID choices for S3, you would either choose RAID 0 or RAID 10, and RAID 10 is recommended. I'm going to choose RAID 10, select both devices, leave the sync mode at standard, and click Create. Now I repeat the same step on SoftNAS 2 using the exact same pool name. Leave it at standard, name it the same, choose RAID 10, select both disk devices, leave sync mode to standard, and click Create. Now I have the same pool created on both SoftNAS 1 and SoftNAS 2. Next, I create a volume. Back at SoftNAS 1, I click on Volume and LUNs in the left menu and then click Create. I give it a name and then I click on the Storage Pool button in order to select the pool that I previously made. For the volume type, I would check the box for Export via NFS for Linux and Share via CIFS for Windows, or I could use a block device like iSCSI LUN, which isn't often used. So I'm going to go with the default file type and check both the NFS and CIFS checkboxes. When we get to choose storage provisioning options, thin provisioning allows a volume to acquire storage from its storage pool on an as-needed basis, as new data is written to the volume. Thin provisioning enables many volumes to share a storage pool without an upper limit being placed on the volume itself. The only upper limit to the volume size is available space in the pool. Thick provisioning volumes reduce the amount of space available in the storage pool by reserving this space for use by a specific volume. When a thick provision volume reaches its maximum volume size, to whatever you set, no more data can be written and a volume full error will be returned for writes to a full volume. Thick provision volumes can be resized at any time to add space or return space to the storage by reducing the volume size. I'm going to leave it at thin provision. Checking the checkbox for compression is recommended to save disk space, and checking the checkbox for deduplication is recommended as well. I'm going to leave sync mode at standard and then click the Snapshots tab. Snapshots are enabled by default. If your app doesn't require this, you can turn it off to save space. You can choose a default schedule from the drop-down, or you can click on the Schedules button and then click New Schedule to choose the exact days and times for daily and weekly schedules to run. Then I set the snapshot retention policy and the size threshold. Then I click Create. Now I have a volume. Now I'm going to click on the left menu, Snap Replicate, Snap HA. If I go to the EC2 dashboard for the second node and I get the private IP address, now I'm going to replicate from the first node to the second node. So when I click Add Replication and then click Next, I paste that private IP of the target node into the IP address text box and click Next. I have to give the target administrator password and click Next. So I click Finish. You can see the visual where it's creating the SS tunnel between the two nodes. Once verification is complete, you can see the source node and target node and that they're connected and see exactly what I just did in the replication control panel. I'm now going to click on Add Snap HA, which will add high availability via automatic failover between the nodes. I click on Next. I leave the selection at private IP, and then I add a virtual IP that doesn't interfere with the IP range that customers use on AWS. And then I click Next twice to install high availability. The next step is to click on the Install button, which configures the high availability for you. Once it's done, I click on Next and then click on Finish. With high availability set up, if a zone goes down, traffic will be redirected to the other zone automatically. We now have our storage automatically replicated between zones, and we have high availability failover set up. So if one availability zone goes down, it's automatically replicated to the other availability zone without any manual intervention.